So your job for today is to be able to compare and order fractions, decimals, and I put in percents because that's part of what your 6th grade standard is. We're not going to be tested this chapter on percents, but we will talk about it right now because it makes perfect sense. If we can find a decimal, we should be able to find a percent. Percent just means out of 100. And so that means that we can find fractions that are out of 100. We can also find decimals that are out of 100. And if we can do that, then we know they're percent. So on your MCAs, you're going to have to be able to do all three. For today's lesson, we need to know what are like fractions, what are unlike fractions, and what's a common denominator. Okay? So like fractions are fractions that have the same bottom number. They have a common denominator. Okay? Unlike fractions are fractions that don't have common denominators. And then a common denominator just means that the bottom number is the same. Okay? So one way that I think everybody can kind of see this trend, one way to compare fractions is by finding common denominators. Okay? And I'll give you a real easy hint. If you want to convert to decimals, we know that one way to find any decimal number is by converting that fraction to 100. And if we can do that, we might as well talk about percents as well. So that's what we're going to be looking at for today. When we have a common denominator, when our denominators are just like each other, it's pretty easy for us to determine whether we use fraction strips. And hopefully most of us are beyond the point where we don't have to use fraction strips, but I want to just show you, okay? This box, so I'm going to circle this box right here. This square represents exactly one whole. And as you can see, this square is represented into 1, 2, 3, 4, 5, 6, 7 pieces. So if we wanted to talk about the entire box, we'd have to have 7 out of 7. Okay? But this box has only 6 out of the 7 colored in. Therefore, it's called 6/7. Now, anytime we're going to compare two fractions, our whole unit has to be the same. So look at this. This box is exactly the same size. And again, it's cut up into 7 pieces. And we like this for common denominators or with fractions because then we can easily see which one's bigger. We can all see that 6 out of 7 is bigger than 4 out of 7. So our alligator mouth would go to the bigger one. And you guys have talked about that before, right? When you're comparing numbers, talk about the alligator always wants to eat the greatest number. Okay? Or sure, for those of you, do you guys actually play Pac-Man? Yeah, I mean, because you could just put the circle here and say, wow, Pac-Man, he wants to eat, okay? Or you could say Miss Pac-Man, it doesn't matter, okay? Everybody understand how we can compare common denominators? Question? Because we're comparing what is actually shaded. Okay? Now, if you did what's not shaded, then it changes things a little bit, doesn't it? Now, all of a sudden, if we say not shaded, well, that's 1 out of 7 pieces is not shaded. So you have to be careful. And usually they're going to talk about the shaded part when they're talking about fractions, but not always. So good question there. Okay? Now, here's another little different representation. Now, instead of our one whole unit being a square, we now shift it to a circle. And whenever I think of circles and I think of fractions, I automatically think of pizza. Okay? Sure, or piece of pie. Fine. Maybe you like pie more than pizza. Doesn't matter. And this one here we know that there are 9 pieces in this pizza, and it looks like you ate 1 of the 9. And this one here, again, same pizza or same size pizza, and 5 of those pieces Eyes here, please. We don't need to be writing right now. 5 of those pieces have been eaten. So that means that's 5 pieces out of the total 9. Does everybody see that part to whole relationship? We've eaten part of the pizza, that's 5 pieces, compared to all 9 of the pizza. So that's what a fraction is a part to whole relationship. 5 out of 9. And we can easily see that this is bigger. Okay? Now when we talk about comparing, usually when we compare, we will use the greater than or less than sign. When we talk about ordering, that means we're probably going to be talking about more than 2 fractions, and in which case we either do from least to greatest or from greatest to least. Okay? So I'm going to move on to the next page. And now we're going to look at things where now our denominators aren't going to be the same. Okay, we're going to have unlike fractions. We're going to compare, and let's read the question to make sure if we truly are comparing. It says, Ray has 2/3 cup of nuts. He needs 3/4 cups to make cookies. Okay? Does he have enough nuts for the recipe? So in other words, is 2/3 cup enough? So we need to compare the two. Here's 2/3. Here's 3/4. Now I want to show you a bunch of different ways that we can do this. The first way is common denominator. Okay? What number will both 3 and 4 go into? The easiest way to do it. I have a feeling, yeah, sure. If we multiply the two denominators together, we're always going to get a common denominator. 3 times 4 is 12. So we can make 2/3 into 12ths, and we can make 3/4 into 12ths. Okay? Now, one way aside from doing that is, and maybe some of you have seen this before, but we can just make an equivalent fraction chart. 2/3 is the same thing as 4/6. Everybody agree? And 2/3 is also the same thing as 6/9. And it's the same thing as 8/12. Look at that. Didn't we want 12ths? Okay. And I could do that same thing for 3/4 and do 3/4 and then just continue and make my little chart and say, all right, I'm going to multiply the top and bottom by 2. 3 times 2 is 6. 4 times 2 is 8. Now I'm going to do 3. 3 times 3 is 9. 4 times 3 is 12. And look at, now we have a common denominator in 12. Okay? So in other words, we're saying 2/3 is 8/12. Would everybody agree with that? Yeah, because we multiply times 4, and then 2 times 4 is 8. Then over here, we say that 3/4 is 9/12 because we multiply by 4 here, and we do it on the top. Oh, sorry, by 3, and we get 9. So now, I compared the two, but did I answer the question? I didn't answer the question, because the question says, do we have enough nuts for the recipe? Kids, do we have enough nuts for the recipe? No. No, 2/3 is smaller than 3/4, so we do not have enough. We have to go to the store and go get some more, whatever kind of nuts we're using for these cookies. I'll wait. Go ahead, question. There's another way to do that, okay? Can we convert any fraction to a decimal? Okay? And these are two that we should know. Everybody should know that 2/3 is 0.6 repeating. Everybody should know that 3/4, if you have 3/4, which that is called, that's 75 cents, 0.75. And we know that 0.66 is less than 0.75. So we could always convert. Okay? So those are some ways that we can do it. Either convert to decimal or find a common denominator. Everybody feel comfortable with that? Good. Let's move on to our next page. Now, here it is. Order these from least to greatest. Now, I'm going to tell you right now, there's one way you can do it without finding common denominators. You want to hear how? Yeah. Estimation. Estimation. Is 4/5 greater than 1/2? Voice, no talking. Is 4/5? How do you know if 4/5 is greater than 1/2? Yeah.
Because half of 5 is half, and 4 is past 2/2.
Okay, so this one's greater than 1/2. Is this one greater than 1/2? 2/3? Yeah. Is this one greater than 1/2? No, it's less than, right? So if we're going from least to greatest, I know 1/3 has to be first because the other two fractions are greater than 1/2. Now all I have to do is compare the other two, right? And now we can either go to decimal. 2/3 we know is exactly 0.66 repeating, okay? Or 66 2/3%, or 67 if we round it up. 4/5 is an easy one because we can make that into tenths or 100ths. In fact, I can make it into tenths really easily. Say it's 8/10. So that represents 0.8, or if I made it into 100, then it would be 80/100ths. That's 80/100ths, or 80%. 80 out of 100 is 80%. Now in this case here, they used the number line to show. And to have a number line really work, we need to have the equal number of units. Do you know how we find where these places go? We have to use common denominators. I bet you anything. Yeah, look at. They have 15. So each one of these lines right here represents, here's 1/15, 2/15, 3/15, 4/15, 5/15. Right here, this would be 14/15, and one whole would represent 15 out of 15. So we could use number lines as well to show these, and you'd be perfectly fine. Okay, so that's what we're going to have to do for today's lesson.